Now let's continue to discuss part C. So part C, we want to find the points where the tangent line is horizontal and vertical. We want to discuss both. The horizontal one, if we can take a look at the graph here. So I actually want you to take advantage of the graph and use it at some point. So the horizontal one seems to me somewhere here, right? Somewhere here, and of course on the bottom somewhere here. And we're going to discuss more in detail here. Actually, this is another place that horizontal tangent line occur there. By the way, when we discuss that, here you have horizontal tangent line, so the angle will be this is the angle we are looking for, right? So that's that we are looking for this angle basically. Okay, now how do we do that? Let's first discuss the horizontal tangent line. So horizontal, that means this is my slope. In order for slope to be 0, the numerator should be 0, but the denominator, you don't want it to be 0. So with that we begin to discuss. So for horizontal tangent line, the numerator should be equal to 0, right? And the denominator, you don't want it to be 0, so that the slope is 0. And let's take a look at the numerator of the dy dx, which is this guy. That's why I did a little preparation when we did part 1. So the numerator, set the numerator to 0, and let's see what happened. Okay, so which means 2 cosine theta plus 1 times cosine theta minus 1 equals 0. So we are going to set the numerator to 0, which means here we do see that 2 cosine theta plus 1 equals 0, or cosine theta minus 1 equals 0, which means cosine theta here is equal to negative 1/2. And here from this equation, cosine theta is equal to 1. Now, cosine theta equals negative pi over 2, negative 1/2. In this interval, you have two angles. One is 2 pi over 2. I mean 2 pi over 3. This is 120 degree, or 4 pi over 3. Okay, so these are the two angles from 0 to pi over 2. And here cosine theta is 1, which is 0 and 2 pi, but 2 pi is the same as 0. They overlap, so I'm going to just write 0. Maybe I skip the 2 pi. Okay, 2 pi will be the same as 0. Let's check these three angles. Let's check these three angles. There's another requirement. The denominator cannot be 0. And these two, if you plug into the denominator, which is right here, right? Which is the denominator right here. So these two will not create problem. The denominator is not 0 for these two values. However, when you plug in theta equals 0 in here, sine 0 is 0. In this case, your numerator and denominator are both 0. So let's take a look at that. Let's look into that then. So now these two are clear. So when theta is 3 pi over 2, 2 pi over 3, and 4 pi over 3, both we have horizontal tangent line. Now when theta is 0, let's take a look at that. In this case, the both denominator numerator, they're 0, so we have to look at the limits when theta is approaching 0, because it's from the right side. Theta is greater than 0. And now the numerator is 2 cosine theta minus 1. I'm sorry, let's not use that particular one. Actually, I now feel it's more convenient to use this guy here, so I'm gonna copy this down here. Now I continue here. Just like I mentioned, I do not want to use this piece. I now want to use this piece, but they are the same, right? So this is my I copy this down here. I'm gonna find my the dx when theta is 0. This is, we already mentioned that this is 0 over 0 type, so the L'Hopital's rule can come in. So let's apply the L'Hopital's rule. X approaches 0, theta approaches 0 from the right. By the way, this is actually the dy dx, right? We are doing this because when theta is equal to 0, we have 0 over 0 type. Therefore, we are trying to do the L'Hopital's rule. Now, when we do the L'Hopital's rule, what do we get from the top? It's going to be, so the derivative of this guy will be negative 2 times, which is negative 4 cosine theta, times the derivative of cosine theta, which is negative sine theta, right? So the negative sine cancel out. We get 4 cosine theta times sine theta. And then the next term is cosine theta. Derivative of cosine theta is negative sine theta. Plus 1 will be gone. And the bottom, like I said, you could either use the product rule, or the shortcut is, think of this as sine 2 theta. The derivative of sine 2 theta is going to be cosine 2 theta times 2, the derivative of inner, which is 2. And then minus the derivative of sine is cosine theta. Now, time to plug in 0 into the theta, right? And because sine 0 is 0, this sine 0 is 0, and on the bottom cosine 0 is 1, and cosine 0 is 1. Now, if you do a little mental math, it will be 0 over 2 minus 1 on the bottom, which is 1, which is 0. So that means when theta is approaching 0, the derivative dy dx is actually 0. So, which actually matches what we observe. There are 3 places, 3 angles that the tangent is 0. So 1, 2, and actually when theta is 0. So at these 3 points, at these 3 angles, theta, we have horizontal tangent line. To do the vertical tangent line, which is should be relatively straightforward now, and the vertical one, the numerator should not be 0, right? And the denominator should be equal to 0. So this is a type of denominator right here. The denominator, if you look at my denominator, which is right here, so I'm going to set the denominator to 0, which means sine theta times 2 cosine theta minus 1 equals 0. And from here, the solution is theta equals 0. And from here, the solution, which means cosine theta must be 1/2, and which means theta is pi over 3 and 5 pi over 3. Now, previously, we already know that theta, when theta is 0, we have a horizontal tangent line, so this cannot be solution, and only these 2 are the solution. Now let's check out the graph. Theta 3 pi over 5, which means I mean pi over 3, which is 60 degree. So looks like 60 degree. Let's move this to okay, right here. So this angle is 60 degree, which is pi over 3, and we do see that the vertical line, the tangent line is vertical. So we found them all. So this is the part problem number 1.